Deep learning can be complicated as there is tons of resources but hardly any explained in simple terms. ChatGPT is all over the internet. You can read about how it works in our previous video. This video we wanted to see how we can use ChatGPT to learn some deep learning concepts. Let's first understand what is ChatGPT. ChatGPT is a prototype artificial intelligence chatbot developed by OpenAI that specializes in dialogue. The chatbot is a large language model fine-tuned with both supervised and reinforcement learning techniques. The base model that was fine-tuned was OpenAI's GPT 3.5 language model, an improved version of GPT-3. ChatGPT was launched in November 2022 and has garnered attention for its detailed responses and articulate answers. In this video we will use ChatGPT to learn some basic concepts of deep learning. But before we do that, please like and subscribe. Let's first understand what neural networks are. I am gonna ask this to ChatGPT to get started. A neural networks are modeled after structure of brain. The network is trained on a set of examples to make predictions or take actions based on new inputs. The strength of the connections between the nodes determines how the network behaves, and the structure of the network can be adjusted through learning. Neural networks can be used for a variety of tasks, including image and speech recognition, natural language processing, and decision-making. What are different components of neural network? Or how to build a neural network? A neural network typically consists of three types of layers: an input layer, one or more hidden layers, and an output layer. The network also has weights and biases associated with the connections between the nodes, can also have other components like activation function, etc. Let's try to understand how to build a neural network. Define the problem you are trying to solve and the data you have available to train the network. Choose a type of neural network that is suitable for the problem, such as a feed-forward network or a convolutional network. Pre-process the data to prepare it for the network, such as by scaling the data or converting it to a suitable format. Choose the network architecture, such as the number of layers and the number of nodes in each layer. Initialize the weights and biases of the network, either randomly or with a predetermined strategy. Train the network on the training data using an optimization algorithm, such as stochastic gradient descent. This will adjust the weights and biases to improve the network's performance. Evaluate the trained network on a separate test set to measure its performance and identify any potential issues. Use the trained network to make predictions on new data. Okay, step seems clear. Let's look at some of the types of neural network. So there are four main types of neural network as per ChatGPT: feed-forward networks, recurrent neural network, convolutional neural networks, and generative adversarial networks. In feed-forward, the data flows in only one direction, from the input layer through the hidden layers and to the output layer. There is no feedback or loop in the network. Recurrent neural networks: these networks include feedback or loops in their structure, allowing them to process data that has temporal dependencies. Convolutional neural networks: they include convolutional layers for images tasks mostly, which apply a filter to the data, and pooling layers, which downsample the data. Generative adversarial networks: these are a type of neural network that consists of two networks, a generator and a discriminator. Let's dive deeper into feed-forward network. In a feed-forward network, the data flows in only one direction, from the input layer through the hidden layers and to the output layer. There is no feedback or loop in the network. The input layer receives the raw pixel data from an image. The first hidden layer applies a set of filters to the data, extracting features such as edges and textures. The second hidden layer processes the data from the first hidden layer, combining the extracted features to form more complex patterns. The output layer produces a prediction for the class of the image based on the processed data from the hidden layers. Let's try to code a simple feed-forward network. Idea is simple. You define the input layer, the output layer, initialize the weights formula is shown in the image on left. Weight of next layer is input weight summed with the learning rate. You loop until you find the output layer. The algorithm is trained using gradient descent. This is basic model with 2 input layer, 2 hidden layer and output layer. Let's slowly walk through the code. We are hearing about activation function, so what it is. Activation functions are a crucial component of neural networks. They determine the output of each node in the network given an input or set of inputs. Activation functions provide nonlinearity, which is essential for the network to learn and make complex predictions. There are many types of activation. Sigmoid function, ReLU are some common ones. In this image you can see what different activation function return. Please pause for a moment to go over it. Okay, so feed-forward neural seems very clear. Let's look at recurrent neural network. Recurrent neural networks, RNNs, are a type of neural network that is designed to process data that has temporal dependencies. This means that the data has some sort of order or sequence, and the order of the data points matters. For example, in natural language processing, the order of the words in a sentence is important because the meaning of the sentence can change depending on the word order. There are many variations of RNNs, including long short-term memory, LSTM, networks and gated recurrent unit, GRU, networks. These variations allow the network to better handle long-term dependencies in the data and avoid the vanishing gradient problem, which is a common issue in training RNNs. During backpropagation, the calculation of partial derivative/gradients in the weight update formula follows the chain rule, where gradients in earlier layers are the multiplication of gradients of later layers. As the gradients frequently become smaller until they are close to zero, the new model weights of the initial layers will be virtually identical to the old weights without any updates. As a result, the gradient descent algorithm never converges to the optimal solution. This is known as the problem of vanishing gradients, and it's one example of unstable behaviors of neural nets. We heard about backpropagation, but what it is? The backpropagation algorithm works by making a prediction for each example in the training dataset, and then comparing the predicted output to the true output. The difference between the predicted and true outputs is used to calculate the error of the network. This error is then propagated backwards through the network, from the output layer to the input layer, to adjust. So far we know GRU and LSTM are two RNN networks. Let's look at what LSTM are. A long short-term memory, LSTM, network is a type of recurrent neural network, RNN, that is capable of learning long-term dependencies in data. LSTM networks are well suited for tasks that require the network to remember and use information from long periods of time, such as language translation or language modeling. So ChatGPT was not able to code LSTM and it just dies and prints part of the code. You can watch partial code or skip to 18. But the code adds gates as part of filtering process. Last type of network are the generative adversarial networks. Generative adversarial networks, GANs, are a type of neural network that is used to generate new data samples that are similar to a training dataset. GANs consist of two networks, a generator network and a discriminator network. The generator network is trained to generate new data samples that are similar to the training data. It does this by taking in a random noise input, using it to generate a synthetic data sample. The discriminator network is trained to distinguish between real data samples from the training dataset and synthetic data samples generated by the generator network. In simple terms, discriminator is a trained guy who can tell what's real and what's fake, and generator is trying to fool the discriminator and make him believe that the generated data is real. With each unsuccessful attempt, generator learns and improves itself to produce data more real-like. It can also be stated as a competition between generator and discriminator. Again, it was not able to code. Anyways, that's all from our side. Please like and subscribe.